speaking from Building IQ, and I'll just, Michael already introduced you a bit, so I'll just let him.
Yeah, thanks for that. So, my name's Adam Benson. I'm from Building IQ. Thanks to the Solar Council for inviting us here to explain our product and our system. I'll talk a little bit. Let's see if my clicker's working. Yeah, it works. So I head up the engineering group here in Sydney. Just talk a little bit about Building IQ. Have people heard of Building IQ before, or even know what we do? I'll talk a little bit about our platform then, and then I'll talk a little bit about solar and obviously introduce who we are and what we're about. So we are a company that actually came out of CSIRO in about 2009. We spun out of their labs up in Newcastle, their building energy group up there, where they were doing a lot of sort of thermal modeling, analytics around HVAC equipment. Since then, obviously, we've grown, we've expanded. We've got offices in New York, San Francisco, and then just recently, our big sort of big moment was we IPO'd on the Australian Stock Exchange in 2015. We've got quite a few buildings under square foot management and a lot of partners and so forth. So that's who we are. And today I'm going to sort of talk about three separate things. I'm going to talk about energy platforms, talk about how our product is used on those platforms, and then I'm going to talk a little bit about some of our services, our core algorithms, and then I'm going to talk a little bit about solar, some stuff we've been doing with NRG in the States. So I'll try to move quickly through some of this and probably get to the solar part where people are probably more interested in. So what is an energy management platform? What is it? What does it do? I mean, we've all heard of building automation systems, building management systems. A building like this has a computer. It drives all the vents, the heating, the cooling. Well, why do I need an energy management system? Well, an energy management system is really sort of the next layer, the more intelligent platform. It's really about taking energy as a whole, analyzing that, and helping drive the building more efficiently. So there's a big difference between a building management system and an energy management system. So traditionally, these 4 points kind of define what an energy platform really is all about. It's about sub-meter data, it's about energy profiles, it's about different data types such as weather, demand response, tariff information. There's a huge graphic visual component to it, and there's a lot of automation. There's two things that we've added to that that's a little bit different on that, and that's sort of this closed loop concept where we have a algorithm, some intelligence in the sky that actually sends commands down to a building, down to devices to actually control those buildings and run it more efficiently. And obviously what's a lot different than the traditional BMS systems is data manager. BMSs traditionally have been designed really about real-time response and control, PID loops, things like that. They're really not designed for multiple different data sets, different data types. And there's really not a lot of analytics and modeling capabilities. They've been designed to store the data for 30 days, 60 days, no more than that. We're talking about energy management systems, data sets that are 2, 3 years old, 4 years old. BMS is just aren't traditionally done like that. How big is this market? What is this market? So the energy management market is growing. It's currently around $2.5 billion. It's growing to about 10. But what's more important is sort of this graphic. I just kind of want to try to illustrate, explain the evolution of the space of building management and energy systems and smart systems. And it's really about, too many movements on here. It's really about these 6 layers of evolution as you sort of progress down the value chain here, this energy efficient value chain. Traditionally, BMS has really been around these physical layers, this data layer here. A lot of them have a visualization layer, which is really report. They do report, this is how my building performed, this is how it operated. They give that to someone, they say, oh, great, thanks. Well, you need to do all these tasks. Someone has to do that. Energy management systems and what Building IQ and what we've built is really about taking it to the next layer. It's analytics, the control layer, and then more importantly, the predictive layer and the automation layer. Taking that information, doing something with it, and automatically changing and adjusting set points. That's really what we're doing. And obviously, as you go up that chain, the data becomes larger, the complexity becomes higher, and traditional building management systems struggle to cope with that thing. So we built a platform that really is about tackling sort of the energy spend in the commercial real estate market. Traditionally, you sort of your CBD areas, your hospitals, your schools. And we built this platform around sort of three things that we're trying to do with it. One is about bringing transparency and visibility about the energy spent at each of these buildings, making that obvious, easy to see. It's about driving operational efficiency. Sometimes just having the information available to the guys in the building makes their job a hell of a lot easier. And then the third thing, which came out of CSR, is really about driving energy efficiency, finding that optimal set point for a building to operate. Just a simple graphic to highlight. I won't get too technical here. We can talk later if people want to. But this is just sort of an abstract diagram of the platform itself that sits in the cloud. Obviously, there's a data layer underneath. On top of that layer are the 5 core services that drive that platform. We have portal, analytics, modeling, alerting layers. Those layers then act upon by our users in various screens. We take a bunch of data sources coming in. Our algorithms generate their own data sets. And then most importantly, the bottom layer, which is the data from the buildings, which feeds a lot of those algorithms, come up from the various buildings. So each and every building is sending roughly 1,000, 2,000 points from each of those buildings getting processed, stored, and held in our system for analytics. Yeah, and then sort of 4 sort of things we try to maintain and promote. Again, just sort of reiterating the same point. If there's any questions, people, feel free to jump in. All right, so I'm going to talk about these are our 3 core services that we offer on this platform. I'm going to talk a little bit, get into the sort of the maths and the science behind our predictive optimization. I'm going to talk a little bit about M&V, create a baseline for your building, an energy baseline, and then just a little bit about managed services. All right, so traditionally, and pardon any sort of any BMS operators in the room, but traditionally, a building sets a sort of static temperature set point for a zone or a building, time of day. They adjust it seasonally. The building has a static 22 degrees, 23 degrees, 25, and they maintain that. We are about actually being more intelligent and measuring, because most space has a different rate of change. It heats and cools at different rates and other things. And we're really about measuring that rate of change. So what we do is we have a mathematical function or algorithm that takes in a whole bunch of data sets, crunches those numbers, and builds a thermal model of those zones or those spaces in the building. And what we actually calculate is just the rate of change, that on a particular time of day, based on outside temperatures, this zone heats or cools at this rate. And we use that to then come up with a more intelligent path to drive the building. That then results in a different looking sort of profile that gets sent down to the BMS of the building, where you might do a charge in the morning. This is kind of simplistic view that is slowed down, but a charge in the morning, and then you let it drift when the energy price is at a higher price, and you save dollars in energy. And that's on a per zone level. So each and every zone has a different one of those patterns. Okay? That's not an easy thing to do. When we first started out with the product and the technology, we all had it in one building. So everything was on site, we had to go into the building, look at it, and then the early part of our evolution, we split that out and we created this sort of hybrid client-server cloud model, this big data vision of that, where we have all the crunching up in the cloud. We have a very small device in the building that receives those signals and acts upon that. And this is this high-level zone control that we're talking about, where we calculate the zone target temperature for each and every space. So this room, the next room would all have their own sort of target temperatures. That would get calculated in the cloud, get sent down, and then we expect the low-level zone control equipment to follow those patterns. And we often find buildings aren't tuned to their specifications. People have left them unattended for a while and just sort of run them down a little bit. And we had to build a whole bunch of other tools, which I'll talk about managed services, that helps us analyze some of those faults that are going on in the building. But that's essentially how we sort of, from the high level down to the low level zone controls of the building. So The machine learning part of Building IQ is this constant learning that the model is doing. So every night it recalculates based on the current data set of data. It calculates a new model. We take 90 days of data. That model gets rebuilt, a new power prediction comes, and then we're able to start producing predicted targets for the next day. And those predicted targets can be moved, adjusted based on pricing and comfort bounds. Key ingredients, and we can play with the weighting of those things too. If a customer wants more comfort at the offset of price or energy savings, we can do that too. Really depends on where the customer's at and that sort of.
Just wondering, if you're building a thermal model, are you doing that on the basis of the theoretical performance of the envelope materials, or are you like giving a thermal pulse and sort of measuring how it dissipates, or how do you actually?
So it's we call it a thermal model, but it's really the rate of change that temperature. So we take in the power, we take the inside temperature. So we build up a model by measuring for about 30 days, 60 days, the actual space in here. And then we take the outside air temperature and we create a relationship between those three things.
Okay.
And that's a thermal model.
Yeah, no, fine.
And it's simple, and it works.
Simple is good.
Yeah.
Are movements in and out of the building and that sort of stuff?
So occupancy is factored in and catered for.
Yeah.
Yep.
So that comes in
So there's occupancy, there's we sometimes use humidity, there's operating scheduled equipment. There's a couple other constants that we adjust as well in there to each and every building, because each and every building is different. School's very different than university campus is very different than office buildings, obviously.
Can you offer demand management to the provider, the energy provider, if they want you to switch off for a while?
Absolutely. Absolutely. So we have some programs in the States where we do nothing but demand management. We will get a signal from the utility that tells us it's a hot day tomorrow, we've got 40 buildings in the portfolio there. They'll send us a signal and they say, I want 60 kilowatts from this building, I want 80 from this one, 90 from that one, and between the hours of 3 and 6, we'll shed that load.